Hello, this is part 4 of the absolute value inequalities examples. Please watch parts 1, 2, and 3 to have an understanding of what I'm going to go through. I will go a little bit quicker in this video because we already have the general ideas down from the previous videos. So here, we're going to try this example. We have an absolute value of 2x plus 3 minus 3 and less than 6. Well, what I need to do when we're set up in this way is I want absolute value of something less than something, right? I do not like this minus 3 in the way, this subtraction of 3. So what I'm going to do is actually add 3 to the right-hand side, okay? And really, I'm adding to both sides. But when you add it, you get 9. And then now we would be left with absolute value of the quantity 2x plus 3. So now we could write a statement that this means the distance between 2x plus 3 and 0 is really less than 9. Okay, so let's make that with the number line. So here's 0, and then 2x plus 3, 2x plus 3, and it needs to be less than 9. So 9 and less than. So I'm going to shade to the left, and negative 9 and a distance less than away, and I'm going to leave that open as well. Notice there's no equality, right? There's no equal to, so I will leave them both open here. Right? So what we've seen before is that we could just take 2x plus 3 less than 9, and then I could make a compound inequality here, because this is my special case where we have the AND statement. We have an AND statement here when we're dealing with less than, right? So we have 2x plus 3 less than 9, and we have 2x plus 3 greater than negative 9. Right? You could think of it as two separate pieces, or just put it together as one. So now I could subtract 3, subtract 3, subtract 3 all the way around, and we would get 2x within the middle here. And then negative 9 minus 3 would really be negative 12. And 9 minus 3 really gives you 6. And then I'm dividing by 2 now to everything. And let me move this next example out of the way. And now we would have x less than, and we'll put our symbols again. Okay, half of negative 12 is negative 6. Half of 6 is 3. And then we could see here, negative 6 is less than x, which is less than 3. Negative 6 is less than 3, so we know that we did make a true statement here. We are happy with that. Now I like to draw another number line just to make sure we match up with what we started with at the beginning. Okay, so it means the distance between 2x plus 3 and 0 is less than 9, right? Now really we've solved that, and we could see that now we have open on the ends, but we can shade any solution in the in-between here, right? Anything in this shaded region is a possible solution. It really is a solution. It definitely is a solution. And I want to put this in interval notation. So I'm going to put negative 6, comma 3, and I'm going to put parentheses because we do not include the endpoints. Right? We do not include negative 6 or 3 as part of our solution. So how about we check this? Let's just check a couple examples. So let's just check off to the side. Well, let's rewrite what we had at the very beginning, right? We had absolute value of this quantity, minus 3 less than 6. Well, let's check. Let's just check x equals 1 is in here, right? 1 is about there. It's between 0 and 3. X equals 1. So let's plug that in. So we'd have 2 times 1 plus 3. Put absolute value around all that. Minus 3 less than 6. Okay, let's solve. 2 times 1 is 2. Plus 3 would be 5. So then we have the absolute value of 5 minus 3. The absolute value of 5 would really be just 5 minus 3 less than 6. Now 5 minus 3 is 2. Is that less than 6? Yes, that is a true statement, so that did check out nicely. And again, 1 was just one possible check. Let's check, let's demonstrate -6. Let's take x equals -6. Now we know -6 is not part of the solution, right? We put parentheses at -6, right? And for a special reason, because if we tried to solve this, let's put 2 times -6 plus 3 within the absolute value bars. We'll subtract 3 less than 6. Okay, so 2 times -6 gives you -12. And then we will be adding 3 and then subtracting 3 outside of the absolute value bar. So absolute value of -12 plus 3, this would really be -9 with absolute value, minus 3, less than 6. Absolute value of -9 is really +9, minus 3, less than 6. So then we have 6 less than 6. Is this true? This is actually false, right? This is a false statement. So that is why we put -6 as a parentheses. We did not want to include it in our solution set. Okay, so that's why we put parentheses. Now we know why. Okay. Really, you could check infinitely many values between here, right? You could check with 0, you could check -0.1, -0.2, -0.3, 0, 0, 0, 1, right? Any value that you want. Okay, let's go on to another example. This is going to be a special example. So let's try absolute value of 6x plus 5 is greater than a -6. Okay, well, remember with the greater than, that was the idea where we're in the river, right? We're standing on a rock and we had to jump to get to the bank, right? Well, here, this is saying that we have to jump greater than -6 feet. This should be suspicious to you, okay? Now, we haven't done an example yet where we have a negative, right? Where you're dealing with a negative. Notice we've always been using a +6. So here, this negative, we're going to have to be extra careful. But let's just pretend we didn't even think of that yet. And let's just try to go through what we're going through as we have been in the past. So this means the distance between 6x plus 5 and 0 is greater than -6. Okay, it's greater than -6. So the distance between 6x plus 5 and 0 is greater than -6. So we know that with the greater than, this is the or statement. So let's just take 6x plus 5 is greater than -6, or 6x plus 5 is less than +6. So let's solve both of these. So subtract 5, we have 6x is greater than -11. So then x, if we divide by 6, then we would have x is greater than -11/6. Or we have, so now we subtract 5 again, we get 1 with 6x, divide by 6, so x is less than 1/6. So we have this, or we have that. Well, let's think about that. When we put this together on the number line, x is less than 1/6, so I'll mark 1/6 here, and I will open it, and I'm going to shade all the way to the left. Or we have, let's mark -11/6, I'm going to keep that open, but I'm going to shade all the way to the right. So you see how when you shade to the right and when you shade to the left, you actually filled in the open circles that happened from before. You actually filled in everything. So actually, our solution here is all real numbers. But then we might be thinking to ourselves, well, why did we go through all this work if it's all real numbers, right? Let's go back to the beginning and think about it, okay? Whenever you have a negative, right, absolute value, and then you're seeing a negative on the outside, on the other side of the equation, you want to stop and think, okay? So stop and think, and you don't have to do any of this work. You don't have to do any of it, okay? Just pause, right? As soon as you see that, you stop, okay? Stop and think. Now, with this other one that we did, with positive 6, you don't have to stop and think. You just go through the motions, okay? You do want to think, right? Don't be a robot. But when you get to these with absolute value of negatives, just stop and think about it, okay? Now, if you stop and think about it, well, we know the solution is all real numbers here. Now, why is it all real numbers? Well, let's look at absolute value of 6x plus 5 is greater than negative 6. Well, we know with absolute value that you have a non-negative, right? A non-negative will come out of the absolute value. And on the right-hand side, we have actually just a negative. Okay, is a non-negative ever greater than a negative? A non-negative is always greater than a negative, right? If you think of the number line, any of the non-negatives, like 0, 1, 2, 3, is always greater than any of these negative values, right? Right? Non-negative values are always greater than the negatives. That's always true. So that's why we had all real numbers as our solution. So how about, let me change up the problem just a little bit, okay? Let me do a new example. And let's just look at 6x plus 5 less than negative 6. Okay, now you see that we have a negative 6 here, so this tells me to stop and think, right? Stop and think. Let me fix that P. Stop and think. So then we have a non-negative, right, because of absolute value. Is this less than a negative? Okay, can non-negative numbers be less than a negative number? That is definitely false. That's never true, right? This is never true. Okay, and if this is never true, then this actually has no solution. So this example right here is a no solution example, which is very different than the greater than negative 6 there, because that one was always true. So you always want to stop and think about it, okay? Think about the way the inequality is pointed when you start messing around with these negatives, okay? It's very special. Okay, thank you for watching my video.